ever wondered how the internet actually works? I mean, really works? It all boils down to this simple string of numbers called an IP address. And just about everything connected in your house has one. Your phone, your watch, your smart light bulbs, maybe even your oven. It's the secret sauce that lets our entire digital world talk to each other. And honestly, calling them pure magic isn't too far off, because that seemingly random string of numbers is the foundation for every single thing you do online. Every email you send, every show you binge watch, every time you order food at 2 a.m. It's all possible because of this universal language of the internet. So in this explainer, we're going to pull back that curtain. We'll start with what your device's address even is, then we'll figure out where these IPs come from. After that, we'll explore how they create these little digital neighborhoods, and finally, we'll do a bit of math to see how many addresses are even available. All right, first up, your device's digital address. For any two devices to communicate, I don't care if it's your laptop talking to YouTube or your smart toilet sending an alert to your watch. They each need a unique identifier. The easiest way to think about it, it's like a phone number. If you don't have one, you can't make or receive calls. Simple as that. In fact, whatever you're using to watch this right now, it has an IP address. And you can find it. Yeah, right now, if you're on a Windows PC, just open up that command prompt and type iconfig. On a Mac or a Linux machine, pop open the terminal and type ifconfig. And if you're on your phone, just dig around in your Wi-Fi settings. Go on, I'll wait. It's pretty cool to see. So that number you just found, that's it. That's your device's unique phone number on the network. But you probably noticed a couple of other addresses hanging out with it, right? Let's meet its two best friends. First up, you've got the subnet mask. We'll call him Mr. Subnet Mask, and his job is super important. He's the one who tells your device what street it lives on in this digital neighborhood. We're going to come back to him in a big way in just a minute. And then there's the default gateway. Think of this one as the UPS of your network. If your device needs to send a message to a totally different street, in other words, to a different network somewhere else on the internet, the default gateway is the one who picks it up and makes sure it gets delivered. Okay, so every device gets an address and has a couple of helpers. But where do these numbers actually come from? Do they just magically appear? Well, kinda. You see that little box with the blinking lights, probably tucked away in a closet? That's your router, and that router is the Oprah of your network. Every single time a new device connects, your router basically shouts, you get an IP address, and you get an IP address, everyone gets an IP address. This whole magical giveaway is a process called DHCP, and it's how your gadgets automatically get their spot on the network. So Oprah, the router, hands out all the addresses. But how do your devices actually use that information? How do they know if they're just talking to the printer in the next room, or if they need to send a message all the way across the world? This is where the idea of a network neighborhood comes into play. Now, let me ask you something. How is it that I can probably guess that your IP address starts with 192.168.1? A little creepy, right? I mean, each of those numbers could be anything from 0 to 255. Well, the answer takes us right back to our good friend, Mr. Subnet Mask. Check this out. Here's a little insider hack to understand exactly what's going on. The whole secret is to see how the numbers in the IP address line up perfectly with the numbers in the subnet mask. That alignment is everything. And the rule here is super, super simple. Wherever you see a 255 in the subnet mask, the number right above it in the IP address is locked in. It will not change for any device on your home network. But wherever you see a 0, that part of the address is changeable. That's the part that makes each device's address unique. This brings our home address analogy full circle. The locked part, the 192.168.1, that's the network portion. That's your street name. Think of it like Privet Drive. And the changeable part? That's the host portion. That's your unique house number. So every single device on your network lives on the same street, but they all have their own specific house number. So this system is perfect for talking to your neighbors, your laptop talking to your printer. But what happens when your laptop wants to stream a movie from Netflix? Netflix doesn't live on your digital street. It lives on a totally different network across town. Your laptop can't just send a message there directly. So what does it do? It calls for help. Your computer looks at the address for Netflix and realizes, whoa, that's not on my street, and it immediately hands the message over to our friendly neighborhood delivery service, the default gateway. And here is the plot twist of the century. You ready for this? The default gateway is Oprah. That's right. The exact same router that handed out all the IP addresses in the first place is also the gateway that sends all the messages out to the wider internet. Mind blown. Okay, now that you know all the key players and how they work together, let's put that knowledge to the test. Let's try a practical challenge that network pros have to think about every single day. Using everything you've just learned, take a look at this really common network. We know the first 3 numbers are locked in by the subnet mask. Only that last number can change. So the question is, how many total IP addresses are possible for all of your devices? If you said 256, you are on the right track. That last number can be anything from 0 all the way to 255, which gives us a grand total of 256 possibilities. So we're good to go, right? We can have 256 devices? Well, not so fast. Because of course, there's a catch. There's always a catch. In any network, 2 of those addresses are always reserved. You can't actually assign them to any of your devices. They have special jobs. The very first address, the one ending in .0, is the network address. Think of this as the leader of the street. It just represents the entire neighborhood itself. And the very last address, ending in .255, that's the broadcast address. This is the network's chatty Cathy. Anything sent here gets shouted out to everyone on the network at once. So yeah, those 2 are off limits. So we take our 256 possibilities, we subtract those 2 reserved addresses, and that leaves us with 254 usable spots. And of course, you gotta remember, your router, Oprah, the default gateway, she needs one of those spots for herself, which means you actually have 253 available addresses for your phones, your tablets, and all your smart gadgets. And there you have it. You now know what an IP address is, where it comes from, and how it works with its friends to get you connected to the world. You've seen how to define a network's neighborhood and even how to count all the houses on the street. But what if you wanted to take one big street and slice it up into smaller, more efficient little cul-de-sacs? Well, that's a process called subnetting, and that's where the real magic begins.
This is the mission statement. It's not just some nice, fuzzy sentiment. The whole point isn't just to pass the test. It's about building real skills you can actually use. And you know what? The best, most effective way to do that is together. So how do we actually do that? How do we tap into all that collective power? Well, it boils down to 4 super simple online actions. Things you probably do without even thinking about it. We're going to reframe these as powerful, strategic tools for active learning. And here it is, your community toolkit. Like, share, comment, and subscribe. I know, it almost looks too simple, right? But trust me, behind each one of these little clicks is a deliberate act of learning. Let's break down exactly what I mean.
First up, liking content. Don't think of this as just applause. Think of it as an act of curation. When you like a video that just perfectly explains subnetting, you're basically casting a vote. You're telling the algorithm and everyone else who's studying, hey, this is the good stuff. This is worth your time. You're helping the best resources float to the top for everyone.
Then you've got sharing. Now, when you share a video with a study buddy, you usually add a little note, right? Something like, dude, check this out. It finally made OSPF areas click for me. That tiny act of explaining why it's so useful forces you to put the concept into your own words. It's a mini teaching moment that cements that knowledge in your own brain. It is one of the most powerful study hacks out there, seriously. Commenting. This is where you become a real active participant. It's not just shouting into the void. When you ask a super specific question like, hey, can you explain the difference between STP and RSTP path costs again? You're not just getting an answer for yourself. You're flagging a common sticking point for the whole community, and you're directly helping to shape and improve the curriculum for everybody else.
And that brings us to subscribing. This one is all about commitment. You know, passing the CCNA requires consistent, structured effort. It's not a sprint. So by subscribing to a quality training series, you're making a commitment to that structure. You're basically telling yourself, okay, I'm in this for the long haul, and I'm not going to miss a single step. It's all about building that solid study habit.
So you see, the really crucial thing here is that these 4 actions don't happen in a bubble. They all feed into each other, creating this powerful, positive feedback loop. Your likes and shares push good content up, your comments help refine it, and your subscription means you get to benefit from this whole ever-improving process. And here's the collective payoff. This is what we all get. High-quality content gets way easier to find. Those tricky knowledge gaps get identified and filled. You end up with a real support network for the really tough topics. And maybe the biggest thing, when you see everyone else engaging in learning, it keeps your own motivation running high. You're all building real-world skills
together.
Okay, let's make this real for you right this second. The theory part is over. For anyone out there who's in that final push towards their exam, it is time to put this exact strategy to work.
You can feel it, can't you? That date on the calendar is getting closer and closer. The pressure starts to build up. This is the moment. This is when having a solid strategy and a strong support system matters more than anything else.
And that is the key takeaway from all of this. You are not alone in this final stretch. That community we've been talking about, it's right here. It's in the comment sections, it's in the study groups, it's in all the shared resources. It is here, and it is ready to help you get across that finish line.
So, the final question isn't about your knowledge of routing protocols or subnet masks. It's this. You have an incredibly powerful network of support literally at your fingertips, and it's all activated with a simple click. The only real question left is, are you ready to use your network to build your future?